Hello, this is Mr. Collier, and today we're looking at trig identities and using it to solve equations and simplify expressions. Okay, here's a basic trig identity. Tan x equals sine over cosine x, or basically the definition of tan in some cases. You can write a triple equal sign here. That means an identity. Okay, that means they're always equal to each other rather than just equal to each other for a specific value of x. So this is a basic identity, and we use that sometimes to solve equations. Like for example, when we have equations with just sine and cosine, you can convert that to tan just by dividing both sides by cosine. And we get root 3 equals, root 3 tan x equals 1, and tan x equals 1 over root 3. That looks like a special triangle, so let's draw the 1, 2, root 3 triangle. Tangent of 1 over root 3, that would be pi over 6, right? So that is x equals pi over 6. That's just one answer between 0 and 2 pi. There's, of course, another answer over here. That angle there is pi over 6, so this angle is pi plus pi over 6. So the other answer is 7 pi over 6. Okay, so that's how you do that one. Let's look at a couple more identities. These identities are, well, you can get them from the unit circle pretty easily. Let's draw this in CAST. So for sine, let's say we have an angle x here, then negative x is down here. One's positive, one's negative, so this is the opposite, negative sine x. For cosine though, they are the same, so that's equal to cosine x. Same thing works over here too, right? If you flip it over, they're opposites. They're the same sign for cosine, opposite for sine, right? And for tangent, tangent is positive then negative, so this is going to be negative tan as well. Which ones are odd and even? Even functions are like x squared, where it's symmetric over the y-axis. You plug in negative x and you get just x afterwards. Anyway, so cosine x is even. Okay, the definition of even is f of negative x equals f of x. And the other two are odd, so sine x and tan x are odd. Okay, you can see that from the graph of sine x. It's symmetric over the y-axis, so cosine is even. We'll use those facts a lot later on. You can get identities for these as well using the unit circle. So this is x, and this angle is pi minus x. So let's write out this again. So for sine, it's going to be exactly the same as sine x. For cosine, it's going to be negative cosine x. And for tangent, it's going to be negative tan x. Okay, so these are identities for those. These are identities that are not in the IB formula booklet. Pythagorean identities you get from the Pythagorean theorem. So let's just draw a triangle on here in the unit circle. So the x value is cosine x, and the y value is sine x, of course. So you can see by Pythagorean theorem, sine squared x plus cosine squared x equals 1. Or maybe you could use a triple identity thing. Okay, so that is always true, and it's called Pythagorean identity because it comes from Pythagorean theorem. So that's in the IB formula booklet right there. But there's also some other Pythagorean identities. So let's take a look at those. Yeah, those come from this identity. You can just notice this is tangent here. Tangent is sine over cosine. So if you divide everything by cosine squared x, then this one becomes tan squared x, and this is 1, and this is secant. So this is the second one, comes from the first one. And if you divide everything by sine, you get 1 plus cosine squared over sine squared is cotangent squared. Cotan squared. And you get cosecant at the end. So you get those three Pythagorean identities all from this right triangle. Okay, let's do a couple of examples. If you know sine and you want to find cosine, you can use this trig identity. Sine squared plus cosine squared equals 1. So this is 4 over 25 plus cosine squared x equals 1. Cosine squared x equals 21 over 25. So x equals positive negative root 21 over 25. You could also always use a triangle because sine is opposite over hypotenuse. You can figure out the other side of the triangle. So you get root 21, and then you can figure out that cosine, sorry, that should be cosine right there. Cosine x equals root 21 over 5, but you know, the angle could be in a different quadrant, so it's positive or negative root 21 over 5. Here, if tangent's involved, you definitely should draw the triangle. That's the easiest way to do it. Cosine's 1 over 4, 1 over 4, so this side is root 15. That means sine equals root 15. Now sine is negative. Cosine's positive, so we're actually in this quadrant. So sine is negative 15 over 4. And tangent is root 15 over 1, or just root 15. Negative, right? Okay, let's look at another example. Let's look at number 5. Okay, when we're proving an identity, we start with one side and prove it equals the other one. You could start with the right-hand side or left-hand side. Usually it's left-hand side though, and it's more complicated looking, so I'm going to start with that one. Oh, they give you a hint already, so let's use that hint right away. Sine squared x plus sine squared x minus 1 over sine x plus cosine x. Okay, so that helps because, you know, the Pythagorean identity is sine squared x plus cosine squared x equals 1. So sine squared x equals 1 minus cosine squared x. So you can write it like that. Okay, and the 1's cancel. So basically on the numerator you got sine squared x minus cosine squared x. In the denominator you got this. You can factorize the numerator. Okay. And you get what's required. You get sine x minus cosine x, so you're done. Okay, so remember, start with one side and work with that. Okay, next we're going to look at number 7 here. Actually, number 7 is pretty much the same thing, just using a different identity. So let's take a look at our identities for cotan. So we have cotan equals cosecant minus 1. So cosecant x minus 1. Okay, so that's cosecant x, squared minus 1 over cosecant x minus 1. So again, you can factorize the numerator. And this cancels, and you get just cosecant x minus 1. Okay, let's solve a couple of equations. So this one here, remember sine negative x equals sine x, or negative sine x. So you get that. So it's just sine x equals 1. And then you can look where sine equals 1. Sine equals 1 at pi over 4 and pi over 2 and 3 pi over 2. Well, actually it doesn't equal at 3 pi over 2. That's sine is negative 1 there. So it's just pi over 2 if you're looking at just between 0 and 2 pi. But actually there's an infinite number of answers. Could be What's next after that? 3 pi over 2, 5 pi over 2, right? 5 pi over 2 also works. But usually questions limit the range, so let's just stick with that one. Let's look at number 3 here. So we got a tan squared. We can just replace that with the formula in the formula book. We got secant squared minus 1. So secant squared minus 1 plus 2 secant x equals 7. This is like a quadratic, so you can, if you like, let y equals secant x. So you have y squared plus 2y minus 8 equals 0 when you rearrange the quadratic. Okay, solve this. We get, now y is secant, so secant x equals -4, or secant x equals 2, right? Remember, secant is 1/4 cosine, so you can say cosine x equals -1/4, or cosine x equals half. You can do this one without a calculator, because that's in the 1, 2, root 3 triangle. We see the ratio half. So cosine, that would be pi over 3. So x equals pi over 3. And there's another answer between 0 and 2 pi right there. If that's pi over 3, then the whole thing is 2 pi minus pi over 3, which is 5 pi over 3. So there's two answers there. The other one, you would have to use your calculator, and let's see, we would have to do arc cosine. Oops, sorry. Arc cosine -1/4, which is 1.82. Okay, so that's one answer. Another answer would be, this 1.82 is over here. The other answer would be 180 minus, or pi minus 1.82 is right there. Is the reference angle, so you got to do pi plus the reference angle to get, you get 2 pi minus 1.82, which is 4.46. So we get 4 answers from that one there.